Good morning. It's a very great pleasure to be here today in this conference called Rev It Up, Revolutionizing the Future Through Emerging Technologies. I would like to heartily thank Pastor Arguelles Jr. At College of Computer Science for the invitation. So as I told before, it's a great and wonderful pleasure to be here sharing something with you today. I will start talking a little bit about digital technologies that have advanced more rapidly than any innovation in our history, reaching around 50% of the developing world's population in only 2 decades and transforming societies. By enhancing connectivity, financial inclusion, access to trade and public services, technology can be a greater equalizer. In the health sector, for instance, all enabled frontier technologies are helping to save lives, diagnose diseases, and extend life expectancy. In education, virtual learning environments and distance learning have opened up programs to students who would otherwise be excluded. Public services are also becoming more accessible and accountable through blockchain-powered systems and less bureaucratically burdensome as a result of AI assistance. Big data can also support more responsive and accurate policies and programs. However, those yet to be connected remain cut off from the benefits of this new era and remain further behind. Many of the people left behind are women, the elderly, people with disabilities, or from ethnic or linguistic minorities, indigenous groups, and residents of poor or remote areas. The pace of connectivity is slowing, even reversing among some constituencies. For example, globally, the proportion of women using the internet is 12% lower than that of men. While this gap narrowed in most regions between 2013 and 2017, it widened in the least developed countries from 30% to 33%. The use of algorithms can replicate and even amplify human and systemic bias where they function on the basis of data which is not adequately diverse. A lack of diversity in the technology sector can mean that this challenge is not adequately addressed. Let's talk a little bit about the future of work. Throughout history, technological revolutions have changed the labor force, creating new forms and patterns of work, making others obsolete, and leading to wider societal changes. This current wave of change is likely to have a profound impact. For example, the International Labour Organization estimates that the shift to a greener economy could create 24 million new jobs globally by 2030 through the adoption of sustainable practices in the energy sector, the use of electric vehicles, and increasing energy efficiency in existing and future buildings. Meanwhile, reports by groups such as McKinsey suggest that 800 million people could lose their jobs to automation by 2030, while polls reveal that the majority of all employees worry that they do not have the necessary training or the skills to get a well-paid job. There is a broad agreement that managing these trends will require changes in our approach to education. For example, by placing more emphasis on science, technology, engineering, and math, by teaching soft skills and resilience, and by ensuring that people can reskill and upskill throughout their lifetimes. Unpaid work, for example, child care and elderly care in the home, will need to be better supported, especially as with the shifting age profile of global populations. The demands on these tasks are likely to increase. And with that, we have the future of data. Today, digital technologies such as data pooling and AI are used to track and diagnose issues in agriculture, health, and the environment, or to perform daily tasks such as navigating traffic or paying a bill, for example. They can be used to defend and exercise human rights, but they can also be used to violate them, for example, by monitoring our movements, purchases, conversations, and behaviors. Governments and businesses increasingly have the tools to mine and exploit data for financial and other purposes. However, personal data would become an asset to a person if there were a formula for better regulation of personal data ownership. Data-powered technology has the potential to empower individuals, improve human welfare, and promote universal rights, depending on the type of protection put in place. Still talking about the future of social media, social media connects almost half of the entire global population. It enables people to make their voices heard and to talk to people across the world in real time. However, it can also reinforce prejudices and sow discord by giving hate speech and misinformation a platform or by amplifying echo chambers. In this way, social media algorithms can fuel the fragmentation of societies around the world, and yet they also have the potential to do the opposite. And we have to discuss a little bit too about the future of the cyberspace. How to manage these developments in the subject of much discussion, nationality and internationality, at a time when geopolitical tensions are on the rise. The United Nations Secretary General has warned of a great fracture between world powers, each with their own internet and AI strategy, as well as dominant currency. Trade and financial rules are contradictory, geopolitical and military views. Such a divide could establish a digital Berlin Wall. Increasingly, digital cooperation between states and the universal cyberspace that reflects global standards for peace and security, human rights and sustainable development is seen as a crucial to ensure a united world. A global commitment for digital cooperation is a key recommendation by the Secretary General's high-level panel on digital cooperation. So with this introduction, I'm going to start now talking about the conscious use technology for innovate advances in the field of renewable energies. Communication and smart network. Let's see how my lecture is going to be, talking about today's steps, how the things are going to go on. We are going to talk about research in Brazil. No, sorry, we are going to starting with smart grids, their benefits, smart grids and microgrids, motivational factors, possible technologies, international and national scenario, and we are going to talk about research in Brazil. The importance of smart grids and microgrids. The smart grids are composed of a series of automations and technologies that mainly aim to provide security, convenience, and sustainability to the energy supply. The new models of electrical consumption require more modern and complex distribution networks. The benefits of smart grids. They have a greater availability of energy to the consumer, lower transmission of and distribution losses, lower environmental impact in case the energy comes from renewable energy sources, reduction in network loading, greater variety in the energy matrix. A smart grid. A smart grid, it's an electrical network that uses information, sensing, and automation technology in order to provide electrical energy efficiently, reliably, and safely. This system uses telemetry in meters across the entire network, allowing communication between everyone involved. Suppliers, consumers, and of course, between machines. The smart grid focuses on the intelligent use of energy, storing it efficiently so that there is no waste. In addition to being sustainable, it optimizes energy management as it much easier to locate when there is an anomaly in the network. Another important feature of the smart grid is the decentralization of power generation. Without the smart grid, as most of our electrical system is today, a single generator produces and distributes power to an entire area. So if something goes wrong, this whole region is without electricity. In the smart grid, small power plants called microgrids produce energy independently and distribute it, connected to the main grid. If there is a problem with the main generator, it disconnects and continues to distribute electricity normally. The impact on the end consumer, the smart grid allows consumers to monitor their energy consumption in real time through smart meters. Generally, only at the end of the month, it is possible to have an idea of how much in total, but with smart grids, it is possible to constantly monitor its use through the computer or a tablet or cell phone. And on the top of that, with everything connected through the Internet of Things, you can program appliances to work at off-peak times when energy is cheaper because fewer people are using it, and thus save money. Industries also benefit from the implementation of the smart grid. With that, it is possible to monitor the amount of energy being spent in each sector of the company and redirect this energy so that it is used more efficiently, which ends up reducing operating costs. The evolution of the electrical network, as we know, it has arrived and promises to benefit the entire chain. As technology advanced, the demand for electricity grew in parallel. However, the energy management and distribution system remains almost the same as last century. How is this possible when we use infinitely more energy? Well, currently in Brazil, 14.7% of energy ends up being lost in the distribution process. A modernization of the current system is necessary, as it clearly does not meet the demand of the 21st century. It is in the context that smart grids arise. Smart grids and microgrids. Smart grids It should be understood more as a concept than a specific technology or equipment. Intensive use of information and communications technology in the electrical microgrid. Most efficient, secure, and manageable way to connect large numbers of small and medium-sized generators to current systems. Connected or isolated operation from the concessionaire. Motivating factors, reliability, drivers, reliability and quality of supply, social and environmental sustainability, favorable consumer empowerment, and favorable regulatory and market framework empowerment, and commitment and development related to the social and environment sustainability. Enabling technologies, automation and digital control of the electrical grid electronic measurement, smart sensor network integration of small and medium capacity, energy generation and storage source power electronics device, distributed generation, microgeneration and storage, integrated communication system as fiber optic, PLC, wireless, etc., enabling technologies. The segments of smart grid technology. We have the infrastructure of communications and automation. We have the communication as the communications substation automation, transmission automation, communicator substation automation, and the integration of prosumer and AMIGD. Transmission automation, systemic monitoring, control and protection schemes, wide area monitoring, protection and control, AAMPACS. Examples, special protection systems, the use of direct information from PMUS for monitoring and control. Substation automation, integration of protection functions, monitoring, data acquisition, oscillography, etc., through intelligent electronic devices. IEDs, intelligent electronic devices, standardization, IEC 61850, etc., communications. Distribution automation, AMR, AMI, automatic meter reading and the meter infrastructure, collect consumer information, making information available to consumers like price signals, demand response, automatic fault detection and isolation, reconfiguration and service restoration, coordinated control of voltage and reactive flow, integration of distributed generation of microgeneration, prosumer and AMI integration, distributed generation systems, ability to control and optimize demand, and real-time response. Distributed generation, microgeneration, and combined electricity and heat cold generation systems capable of substantially reducing energy consumption from the grid and eventually supplying energy and the grid ability to control and optimize demand and local generation through the internet and other communication and information processing mechanisms in real-time response to energy price signals and demand reduction requests to support utility system security. A typical microgrid configuration. We have here the DCR that is in red, the disjunctor in green, The dark red is the the source controller, and we have the charge controller here. International scene, international organization, USA. We have GridWise, a modern grid initiative like DOE, and IntelliGrid, EPR in Europe. Smart grid companies, traditional, ABB, Siemens, Revenue, IBM, Oracle, Cisco, Google concessionarily, Enel, 30 million telemanagers, Portugal, EDP, InnovGrid projects, and Energy Box. The national scenario. Special protection systems, ONSPMU applications, PMU network for oscillography, and state estimations, ONS security monitoring and control, ONS, and CPEL, phaser measurements of pilot projects. UFSCO online monitoring of voltage stability. COPPE and CESI, distribution, centralized electronic measurement and automation. We have EMPLA, Light, Eletropaulo, CEMIG, etc., communications, PLC, BPL, and others. Opera, Samba, and the digital village of Barreirinhas. APTEL, regulation public consultation on electric measurement, ANEEL. More design is needed on solar panels, wind generation fall, cell wave, energy simulation, and biodiesel generation. And some considerations are necessary. Real alternatives for optimizing the quality of electricity supply are technologies necessary for its implementation, available at reasonable costs. Fundamental question: what is the assessment of the impact of these new technologies on the cost of energy for the final consumer? The topic is relevant and worrying. It has generated some discussions in the business and academic spheres. So I will present our research carried out in Brazil. Paths of smart grids, global analysis from a scientific and intellectual point of view. Objective, it was to present a time frame of the world's most significant scientific and intellectual industrial activities related to smart grids. Introduction. The natural phenomena caused by solar and gravitational energies have always instigated human beings to capture their effects and use them for their benefit. The natural phenomena caused by solar and gravitational energy, have always instigated human beings to capture their effects and use them for their benefit. For example, heat and hydrological cycles were and will continue to be the main means that allow the generation of electricity, a key factor of the economic and social development of nations. The Brazilian electricity sector faced a serious energy crisis between 2013 and 2015, exposing the fragility of the country's generation system and rising concerns about the decentralizing and diversifying its electricity matrix. We have Silva and Carvalho here. The Brazilian electricity sector faced a serious energy crisis between the years I told you, the 2013 and 2015, where the fragility of the country's generation system was exposed. In this sphere, distributed generation finds ways to spread in Brazil, followed by a lack of knowledge of the effects, both technical and environmental, of the use of this resource in the Brazilian electric system, according to Carvalho and Delgado 2017. Smart grids on the most dynamic and essential systems for human beings is energy supply for economic and social development. One of the most dynamic and essential systems for human beings is energy supply for economic and social development. Faced with this, the traditional model of electricity generation based on hydrological mechanisms, centralized, is faced with modern networks which use the concept of smart grids, presenting innovations to obtain greater flexibility, such as the insertion of generating units, decentralizing the system, configuring the distributed generation. Generation and distribution. Distributed generation means that the source of electrical energy is near or close to consumers, regardless of power, technology, or energy source. And it is becoming more and more important in energy systems, decentralizing them and causing a transition, according to Kublai, Uli Beer, 2018, and Rosa, 2016. Distributed generation means that the source of electrical energy is near or close to consumers, as I said before. And it is becoming more and more important in energy systems, decentralizing them and causing a transition. The dynamics involved in this transitory process are difficult to predict. Therefore, they represent a great challenge for stakeholders in the energy chain. A systemic analysis of the innovative technological aspect needs to be essential to reach a holistic understanding of the interaction of the different elements of DG and to create better technological solutions. Technological prospecting. Advanced countries and institutions increasingly place an emphasis on foresight processes, which create spaces for structured dialogue with a focus on systemic or transformative innovations. Advanced countries and institutions increasingly place an emphasis on these processes, which create spaces for structured dialogue with a focus on systemic or transformative innovations in Brazil. The National Institute on Industrial Property, the INPI, is the body that uses patent documents as a source of technological and statistical information to improve and disseminate and manage the Brazilian system for granting and guaranteeing intellectual property rights. For Brazil, whose socioeconomic development is still incomplete, one of the challenges is to increase the competitiveness of the national industry, which largely depends on the innovative capacity. This premise depends on increasing business investments in research, development, and innovation. RD&I and encourage projects with greater and better technological content, riskier, but which pay off, as they add more robust barriers against competition and can produce greater economic impact. Brazil's innovative technological activity shows a continuous trajectory of distance from countries considered to be the most innovative. Global Innovation Indexes 2011 and 2018. One of the reasons for Brazil not having a very good performance in terms of innovation is the internal economic scenario, like inflation targets, floating exchange rates, primary surpluses, and expenditure cuts, which tends to undermine the effectiveness of industrial and innovation policies. The country has entered a zone of considerable economic turmoil with several short-term political constraints. To recover, it will be necessary to adhere a long-term innovation commitments and results in an intelligent and rational way, like YIPO 2016 says. Despite this, Brazil has considerable infrastructure and critical scientific and technological mass, both public and private, for R&D projects. However, these end up meeting the demands of innovation projects in the industrial sectors in limited way, due to the difficulties of planning, management, risks, and the lack of human resources dedicated to innovation. Embrapi 2015 is the source of this information. The indication of technological trends related to the activities of intellectual and scientific production can suggest potential paths for the creation of research and development projects. Descriptive analysis, scientific articles. After collection on the Web of Science and Scopus platforms, the data were organized in Microsoft Excel spreadsheets by year. This search returned a sum of 8,730 scientific articles, identified with the term SMART GRIDS in their title, abstract, or keywords by Web of Science, and 9,454 scientific articles by Scopus. After calculating the total number of publications evaluated between 2008 and 2018, the first 5 countries with the highest publication rates were listed. So we have here China, United States, Canada, Italy, United Kingdom, and South Korea. From the identification of the 5 countries with the highest number of registered publications, it was possible to analyze an annual evolution of their deposits by the Web of Science. An annual evolution of its patent filings. We have here Canada, China, Italy, South Korea, United States again. The behavior of each of these countries is presented separately, and a possible linearity can be observed in the annual registration in countries such as the United States, South Korea, Canada, and Italy. Final considerations. The main objective of the work was to present trends capable of assisting in the identification of scenarios from smart grids from a scientific and intellectual point of view. For Brazil, to improve its activity in the items 163 researched in this work, it is possible to give more emphasis to the resulting aspects, using in a strategic way what is the best practices, who and what are doing. The main objective was to present trends capable of assisting in the identification of scenarios for smart grids from a scientific and intellectual point of view. For Brazil, to improve its activity in the items 133 researched in this work, it is possible to give more emphasis to the resulting aspects, using in a strategic way what the best practices are doing, who and what. As for the analysis of intellectual production patents, it can be seen that the curve that represents the activity of registering patents in China has a behavior similar to an S curve, demonstrating a relatively high level of variation. And the trend suggests that it is slightly decreasing. South Korea was ahead of China in mid-2013 and then showed a decline. However, in 2018, South Korea shows signs of a return to growth. The USA is also reinforced as a country of attention for the coming years in this regard. Thank you very much for listening to me in this special conference. Thanks for the invitation and have a good conference ahead. Thank you very much.